To session 4. In session 4, we will be discussing a few more aspects of class modeling. Before entering into session 4, we will have a recap of what we had discussed in the previous sessions. So in the previous sessions, we understood the requirements of the clients are modeled using a very popular design modeling called as object-oriented modeling. Okay. Now, how exactly things are put into frame in object-oriented modeling? So that is what was discussed in the previous sessions. So the real-world entities in the requirements of the clients are identified as classes. So what is a class? And what are objects and how they are related to a class? So these things were explored in the previous sessions. We also understood the characteristics of object-oriented modeling. We understood few powerful features in object-oriented modeling, object-oriented design, which has really made this specific aspect of the design very flexible and powerful. So a few highlighting characteristics that we had discussed was abstraction, polymorphism. Also, we understood object-oriented themes like encapsulation, through which we could ensure data is secure in a class. Now, continuing with that discussion, so we shall discuss what link so links and associations. So this will be the very first topic under discussion. Next, generalization versus specialization. And finally, we had a recap of what are the topics that were covered in the previous session. So in today's session, we will be discussing different aspects of class modeling, which includes links and association, generalization versus specialization, and also multiplicity. Okay. So these topics will utilize the basics of classes and objects that were discussed in the previous sessions. So we had a brief recap of it. Okay. So to start with, so first we will take up generalization versus specialization. We will try to understand what is generalization and what is specialization in the context of a class. Okay. So generalization versus specialization. What exactly is this in terms of class modeling? Okay. See, as we understood in the previous discussions, we can have multiple classes as part of the design. Okay. So when you are designing a system, when you are coming with a blueprint for a software, so you can have different classes. Maybe I'll call it as class A, class B, so class C. So in object-oriented modeling, as part of the design, you can have different classes. Okay. Now, we also understood each class can have subclasses. For example, class A can have subclass 1, it can have subclass 2. So classes and subclasses represented in a hierarchical relationship, okay, is what is addressed in generalization versus specialization. So basically it's all about classes and subclasses, how exactly they are arranged in the form of a hierarchy. Okay, so that is what is graphically depicted and represented in generalization and specialization. Okay. So we'll try to explore the details of it. First we would take up generalization. What exactly is generalization? Okay. So in generalization, what exactly we are doing? So we combine the subclasses. For example, have few subclasses, subclass 1, subclass 2, one more subclass we have, maybe subclass 3 and even subclass 4. Okay. So in my example there are 4 subclasses. Now we will assume subclass 1 and subclass 2 is having attributes and operations which are closely similar to one another. So few attributes in subclass 1 can be combined with subclass 2. In that case, so I'll combine this and I'll create a generalized version of these two subclasses. Okay. So whatever attributes and properties were shared between subclass 1 and subclass 2 has been combined and a general class has been formed. Okay. So we call it as a superclass. In this case, superclass is a general class. So what exactly we have done here? So we have moved from specialization. So our subclass is a specialization here. So this is specialization. So each subclass was having its own specific attributes and functions. So that is the reason we have called it as specialization. And from specialization, we have chosen few attributes which were common between the subclasses and we have come out with a superclass. And that is a general class. So this process of extracting shared characteristics in 2 or more subclasses and combining them to form a general superclass is what we call as generalization. Okay. So in generalization, we create superclass from existing subclasses. Now continuing with this example, now you can see 2 more subclasses here, subclass 3 and subclass 4. We will assume subclass 3 and subclass 4 are having few properties, few attributes, few functions which are common to each other. They are closely related. In that case, we can apply the same old philosophy that was just now discussed. So we can combine subclass 3 and subclass 4. We can combine the attributes and functions in subclass 3 and subclass 4, and we can come out with a superclass. I'll call it as superclass 2 just to distinguish it from this one. This is superclass 1. So subclass 3 and subclass 4 have been combined and a superclass has been derived. What exactly we have done here? So if you carefully observe, we have created a superclass which is a general class from a specialized class. So as already mentioned, subclasses are specializations, special classes. So subclasses are specialization with its own attributes and functions. From the specialization, you have moved to generalization. Okay. So what exactly we have done here? So in generalization, so we have extracted the characteristics that are shared between the subclasses. We have extracted the functions shared between the subclasses and we have combined it and we have formed a superclass which is nothing but a general class. Okay, a specialization to generalization. So this is the process. So ultimate outcome is from the existing subclasses you are creating a superclass. So this was all about generalization, and you can also observe a hierarchical relationship has been formed. Okay, so our superclass is in the topmost level in the hierarchy, and our subclasses are at the next level. So we created a hierarchical relationship here. So this was a generalization. Okay. To improve our understanding, I'll take a more specific example. Okay, for generalization. So let us consider a few vehicles like car, bus. Okay, we'll assume car, bus are the subclasses. Okay. Ship, boat, two more subclasses. So one more set of subclasses we have created, aeroplane and helicopter. So these are the specializations that we have. Okay. Why it is a specialization? Because each class has its own unique properties and attributes. For example, a car has its own unique property using which we can distinguish a car from a bus. In similar lines, a bus can be distinguished from a ship or a boat through its own properties and attributes. So it's a specialization. Okay. Now, can you create more general classes? Can you move from specialization to generalization? So that is the question in front of us, and definitely we can do it. If you once again do a basic analysis, we can understand a car and bus is a vehicle which is moving on the land. Okay. So I can come out with a generalization here. What is it? So a car and bus, so it is moving on land. In similar lines, a ship and boat. Okay. So they traverse on water. Aeroplane and helicopter, so they use air as a medium for traveling. So this was one level of generalization. Okay, so we have generalized car and bus to be vehicles which are, car and bus are the ones which are moving on the land. So from specialization we are moving to generalization. So a car can move on land, a bus can move on land. Ship and boat, so both can move on water. You can see from specific instances we have moved to a general instance. Now can we take this specialization further to the next level in the hierarchy? So it's definitely we can do it. So there is something that is common between all these three levels. What is it? So a car which is moving on land, a ship which is moving on in water, and an aeroplane propagating in air. So all are vehicles. So all are vehicles. Now did we come out with a general class, okay, from a subclass? Yes, definitely we have done it. So we have moved from specialization to generalization. So from a subclass we have come out with a superclass which is having characteristics and properties similar to all the subclasses. Okay, for example, you consider a car, you consider a ship, you consider a helicopter. Okay, so all are vehicles which are moving, which can move. Okay, so which can take the passengers from one place to another place. Okay, that is a common characteristic, common operation between a car, ship and helicopter. It can move maybe forward, turn left, turn right. These are operations it can do. It can carry the passengers. Okay. So it will have a seater. It will have doors. So from a subclass, we have identified few aspects which are common, and we have tried to generalize it. And in this example, the generalization we have done is, so all these subclasses, all these specific cases, specific classes can be brought under the umbrella of a superclass called as vehicles. And this is what we have done. And this is what generalization is all about. Okay. And add on to this, a generalization is represented by what is called as is a kind of relationship. So we represent generalization using is a kind of relationship. Okay, what exactly is this? So I'll take a few specific examples for more clarity. For example, car. Okay, so car is a kind of what? So vehicle. So we can see the subclass car, okay, is being indicated as being a kind of vehicle. Okay, that is a relationship here. Okay. In similar lines, ship is a kind of vehicle, okay, moving in water. So car is a kind of vehicle moving on land. Oh, sorry. So this was all about generalization. Now what is specialization? Okay. So specialization is the reverse of whatever was discussed as generalization. So what happens in specialization? Okay. So in specialization, we create subclasses from the existing superclass. Okay, so we will have a superclass. We'll consider the same example. Okay, assume I just have this superclass vehicle. I just have this data. Okay, so from the superclass, I need to create subclasses. So can I do it? It's definitely, and that is all about specialization. Okay, it's a reverse of it. For example, I will start from this point. I'll start from vehicles. Next, I will categorize vehicles to be of three types: vehicles which move on land, vehicles which move in water, and vehicles which move in air. Okay, so I'm moving from generalization. So we can see that. So I started with a generalization, that is vehicles. I'm moving to the next level in the hierarchy, and I'm going into specialization. Okay, so now I identified vehicles which move on land. I have categorized it. I have classified it, which move in water and which move in air. Now, can I take this to the next level? Can I identify few more subclasses which are specializations of this class? For example, can I identify different types of vehicles which move on land? Can I identify different types of vehicles which move in water? Yes, definitely I can do. So the same has been indicated here. So on land we can find vehicles like car, okay, bus. So in water we can find different types of vehicles like ship, boat. The same is applicable here. So in air we can have different types of vehicles like aeroplane and helicopter. Okay. Now what exactly is this? So from a general class, from a super class, we are moving towards a subclass which is more specialized with its own unique characteristics and operations. Okay. For example, a car may be a vehicle, bus is also a vehicle, ship is also a vehicle, but a car has few attributes which are very specific to it compared to a bus or a ship. Okay. So we have moved from generalization to specialization. So this was all about generalization and specialization. We understood. Basically, generalization and specialization is used to either combine subclasses and to come out with a more general superclass, which is generalization, or take a superclass and come out with subclasses which are more specialized. Okay. In either way, in either case, the properties and attributes are carried from a superclass to a subclass, or vice versa, that is from a subclass to a superclass. Properties, attributes which are common, so they will be carried. So this was all about generalization and specialization. So this was the very first topic under discussion. Next we will take up links and association. Links and association. What exactly is this? Okay. Now, in the previous sessions, we understood when you are coming out with a design in object-oriented modeling, so you will be coming out identifying classes and objects. So classes are groups of real-world entities, so which are having common properties and operations. And objects are instances of the class. So this is what we had understood in the previous sessions. Now, I have a set of classes. It is not like only one class will be there in a specific design. We understood software engineering is dealing with softwares which are complex, meaning that there will be hundreds of classes. For example, class A, so class B. Like this, we can have hundreds of classes as part of a design, as part of a complex design. Okay. Now, how these classes are related to one another? Like how class A is interacting with class B. How class B is interacting with class A. Okay. How they are related, how they are communicating with each other. So that is represented using what we call as association. So association is how a class which is part of the design, okay, is interacting with a different class. Okay. So that was association. So typically we will have 2 or more classes. One more point we need to note down is the interaction or association between the classes will be represented by using a straight line that will be connecting the 2 classes. For example, I want to represent association between class A and class B. So I'll draw a straight line between class A and class B. What exactly is that association? So I can write above the line, okay, and usually it will be a verb. I'll go to more specific examples so that we can have more clarity about this. For example, consider 2 classes, student class and a university class. So assume we are building a software, okay, so which is managing the colleges and universities. Okay, so 2 classes I have handpicked for this specific explanation. Okay, student class and university class. Now we are trying to understand what is association. So just now we had a very formal definition. Association indicates how one class, for example student class, is related to or is communicating with university class. Okay. For example, to indicate they are related, they are communicating, I'll draw a line. How they are related? I'll write above the line in the form of an action word. Okay. Like for example, so student studies. So student studies in a university. You can see studies is a verb, action verb. Okay. So that is demonstrating the relationship between a student class and a university class. Okay. So this is what association is all about. Okay. Now we understood what is association. Then what is link? Anyhow, we have used a link here. Even in association, we have used a link. Okay. Now, to be more specific, we will see what is link. Okay. See, this was a class diagram. So, association is typically representing a class diagram, a class model. We saw a student class, university class, class A, class B. Now, what is link? Okay. So, link is dealing with representation of relationship between objects. Okay. So, we understood what is an object. Okay. So, now we are discussing what are links, classes, different classes and how they are related. So, that is being addressed by association. Okay. So, objects, different objects and how they are related. So that is addressed by links. Okay. So for a link you need to have an object diagram. So it is all about object diagram. For example, for the class student, I will create different objects. So in the previous sessions, we had a discussion about what is a class and what are objects, how an object is created or associated with a class. How we can achieve flexibility using this class model, using this object oriented modeling. So all these aspects were covered in the previous discussion. Okay. So with those things as basics, I will continue with this example. Okay. So we have class student. So hundreds of students can be there who are studying in university. Okay. For example, I will create one object for the class student. Student by name, for example Anil. So please note Anil is a student. Okay. Anil is an object in this example. Anil is an object belonging to the class student. Now how many objects I can create like this? So as per the previous discussions we understood, you can create infinite number of objects. You can create as many number of objects supported by your computing resources. Okay. So it is student Anil. I can create one more student. So I created one more student by name Sunil. Okay. So who is Sunil? Sunil is a student. Sunil is an object of class student. So two objects have been created. Now what is a link? Okay. Link is talking about how the objects are related to one another. How an object is related to maybe a different object. How an object is related to a class. How they are communicating. So all these things are represented using links. So link is basically dealing with objects and association is basically dealing with a class. Okay. Now in the specific example, so Anil and Sunil are students. Okay, students belonging to which university? So I'll create one more object. See, there can be hundreds of universities across the country or across the globe. So I'll create one university object. So I'll name it as VTU. Okay. So I created one university object VTU. Okay. So now the fundamental essence here is how the objects are related. That should be represented, and we are using links to represent it. So how it can be done? So I will draw a line between Anil object and the VTU object. I will draw a line between Sunil object and VTU. What does it mean? What does it indicate? So it means that Anil object, Sunil object are related to the VTU object, or to put it in a more general way, Anil and Sunil are students studying in VTU. Okay, so that association I can write above the line as explained previously. For example, student studies in university. So in similar lines, Anil and Sunil are objects who are studying in. Okay, so they are studying in VTU. Please note, this is a verb, action verb, indicating how. So the student objects are related to the university object. Okay. So the bottom line here is association is used to represent how classes are related to one another, how classes are communicating with one another. Okay, and this is a way of doing it. So write the different classes and how exactly they are related. So indicate it through a straight line, and type of relation can be written above this line, which should be a action verb. Okay. So if you are trying to represent the different objects and relationship between the objects, you need to use links, wherein which you will be writing the different objects and how those objects are related to one another. So you will use a straight line to indicate the exact nature of relation. So you can write an action verb above the line. Okay. So this was links and association. So in the last part, multiplicity. What exactly is multiplicity? So multiplicity specifies how many instances of a class, okay, is related to a different class, or how many instances of an object is related to other objects. Okay, how many exactly, to be more specific, it is the number of instances. Okay, so it specifies the number of instances. So what are the possibilities here? How many instances we can have and how exactly it is represented? So we will be taking the UML example, UML modeling to represent multiplicity in classes and objects. Okay. So UML is Unified Modeling Language. So it's a standard way of visualizing the design of a system. So from the beginning of module 2, we are trying to depict the design of a system before starting the implementation. Okay. So we need some standard models, some standard way of representing this design, and that can be done using UML. So Unified Modeling Language. Okay. Now using UML, using the rules specified in UML, how we can represent multiplicity. So that is what we will see in this part of the discussion. Okay. So multiplicity can be 1. Okay, that is exactly one instance. So there can just be one instance, exactly one instance. Okay. For clarity, I'll take an example. I'll take two classes. Okay. One is the country class. Okay. And the other one is the capital. So country class and capital class. Two classes are there. As explained, these two classes are represented, the relationship between these two classes are represented using association, that is by drawing a line between these two classes as explained previously. Now, how many instances of this class, country class, are related to the capital class? That I need to represent here. See, generally we know one single country can have only one capital. So we cannot have more than one capital cities in a country. Okay, so that is the basic general knowledge. So in this case, I can mark this one 1 meaning that one country having one capital. Okay, meaning that any one specific country across the globe so will have only one capital. Okay, so this has been indicated by one instance. Okay. So the action verb that I can write here is as. So a country has one capital. One country has one capital. Okay. So this was a class diagram marking the association between the classes. Can I have it for an object? Okay. Using links. Using link, can I do it? Yes, definitely. For example, country. I'll write the name of the country here. Name, for example, I'll write as France. Okay, now France is an object of class country. Okay, now I'll create one more object here of the capital class. So for the capital class, I'll create one more object by name Paris. Okay, so I created one more object here. Okay, so now how these two objects are related? As usual, draw a link, draw a line, indicate the instances. France, which is a country, has one capital city. Okay, that is Paris. Okay. So this was exactly one instance. This was an example for exactly one instance. Okay. The second case. So in the second case of multiplicity, so I can have asterisk. Okay. So this denotes 0 or more. Okay, it denotes 0 or more. So now I'll take a different example so that we can have diverse examples which improves our clarity. Okay. Consider this scenario. Okay. A student class and university. Okay. To be more specific, I'll name the university as UBTU. Okay. So now, how many instances of student class can be related with VTU? University. Okay, how many instances? Okay, definitely there is a relation between the student class and university class that I will indicate by a link or a line. Okay, now how many instances of students are possible here? So it is not 1, it is not 2, it is not 0, so it is more than 1, so indicated by asterisk, meaning that there can be n number of students and all these students are associated with what? One university, which is that university, it is VTU. Okay, so n number of students, okay, or more than one students are studying, so they are studying in VTU, so that is a relation. Okay. This was the multiplicity where multiple instances are being denoted. So please note, multiplicity is specifying how many instances of a class is associating or relating with a different class. How many instances of an object, okay, is relating with a different object. In the previous example, we saw it was only one instance. Okay, one country having one capital. In this example, we can see many instances, many students being associated with one single university. Okay. A third way of doing it, third representation, third notation in multiplicity, I can write like this: 0, 1. What does it mean? Okay, I'll go to an example so that we do not confuse with what exactly is this. Two classes are there. One is the person class, the other one is the car class. Okay. Obviously, these two classes are related. Person can have a car. Okay. So I'll indicate it through a link, which is association. Now I need to write the instances. How many persons? How many cars? Okay. So I'll write like this: 0, 2 dots, and 1. Okay. And here also at the other end, I'll mark this: 0, 2 dots, and 1. What does it mean? Okay. What is a 0 here? Okay. So even if a person does not have a car, no problem. This relation holds good because 0 person. Okay. So if a person does not have a car, this design is accepting because 0 person, 0 car. Okay. 1 person, okay, having 0 car, meaning that a person does not possess a car. Is this relation accepted as part of this design? Yes, because 1 and 0. Okay. If a person is not having a car, it is accepted. So can a person have a car, have 1 car? Yes, definitely. That is also accepted in this design because with person you have 0 or 1. Okay. So one single person having 1 single car is accepted. Now what if a person is willing to have 2 cars? Okay. Now is this relationship, is this scenario accepted by this design? A person having 2 cars. So this will not be accepted because as per the design, maximum is a person can just have only 1 car. Okay. So that was a range specificity. So we can have integer ranges like this to represent multiplicity. Okay. I can take one more example with an integer range. For example, I will take it as a different example. For example, I will have like this: 2, 5. Okay. This is also a multiplicity rule specifying the number of instances. A class is related to a different class, or object is related to a different object or a class. Okay. I'll give you a specific example here. Okay. A customer. So a customer So now in this example, 2 classes are there. One is the customer class, the other one is items, ordering of items. So I'll mark this multiplicity relationship 1, okay, and 2, 5. This is what I have marked. Okay. What does it mean? So one single customer ordering 1 item, is it accepted as part of this grand design? One customer ordering 1 item. No, it is not accepted. What is the reason? Minimum, a range is specified, minimum he should order 2 items. A customer should order 2 items for the transaction to be completed. Okay. So a customer is ordering 2 items, yes, it is accepted. Customer is ordering 3 items, yes. Customer is ordering 4 items, yes. Customer is ordering 5 items, yes. Okay. Why all these stuffs were accepted? Why this was not accepted? A customer ordering only 1 item? Because as per the design, in the object-oriented modeling, we have specified a customer, one single customer should order a minimum of 2 items. Okay. Now, what if a customer is ordering 6 items? Is it accepted? No. It is going out of range. Please note, this is an integer range in multiplicity. A customer ordering 6 items, so the design does not support it, so it will be rejected. So this was integer range. So in today's session we saw a few more aspects of class modeling. We explored what is generalization, what is specialization, how using generalization and specialization we can create a more general class which is a super class, or we can create subclasses which are more specialized. We also understood how we can create relationship, how we can represent relationship between the classes, between the objects using link and association. Because we will have n number of classes, we will have n number of objects in object oriented modeling. Okay. These classes and objects are not independent, they are related to one another, they communicate with one another. How exactly they are doing it is represented using links and association. Okay. And the last part of the discussion was multiplicity, okay, where we understood multiple instances of a class, multiple instances of an object can be interacting, can be related to a different class or objects. Okay. So that was represented using the multiplicity. So thank you.